Okay, good morning class. So today we're looking at exercise 11.8. Did we do up until 11.6, 7, 8? Yep. 11.8. Odd numbers, and that's on page 380. Okay. So in exercise 11.8, we are told convert a nominal interest rate of 7.8% per annum compounded monthly to an effective annual interest rate compounded annually. What's my formula? 1 plus I effective equals 1 plus I nominal over m to the exponent. So this is a nominal compounding, not so. They ask to convert that to an effective. So I want to calculate R effective. So it's going to be 1 plus I effective equals 1 plus. Come people, 1 plus what? 0,078 over 12, because that's monthly, to the exponent. 12. If it was quarterly, I would have put it over 4 to the 4. But semi-annually, over 2 to the 2. Daily, over 365 to the 365. Okay. So what do I have to do here? We take 1 over the equal sign and then I multiply it by 100. So it becomes, open brackets, 1 plus 0,078 over 12 to the exponent 12 minus 1. Multiplied by 100 gives us 8,08. Is there any confusion there? Yeah. Let's go to number 3. Number 3, they ask you to convert a nominal interest rate. A nominal interest rate of 9%, 9.2% per annum compounded daily to an effective annual interest rate. What's my formula? 1 plus I effective, that's what I want to calculate, equals 1 plus I nominal over m to the exponent. Okay. So it becomes 1 plus I effective equals 1 plus 0,092 over 365 as it's daily, the 365. So what do I have to do? I take that 1 over the equal sign and then multiply it by 100 to get the rate. There we go, open brackets, 1 plus 0,092 over 365 to the exponent 365 minus 1. So I effective is 0,09635 and the number carries on. I then multiply it by 100, which is 9,64%. Okay? Any confusion? Number 5. Determine which of the following interest rate would provide the best investment option. So one of two things, I can either choose 1,000 Rand and then work out 7% compounded annually on 1,000 Rand, 6.9% compounded quarterly on 1,000 Rand, 6.85% compounded monthly on 1,000 Rand, and see what is the best return. Or can you convert all of this to effective compoundings? Okay. So that is a compounded annually, so I'm going to convert everything else to annually. You see that, people? So let's go with B. So B is going to be 1 plus I effective equals 1 plus I nominal over m to the m. So it's 1 plus I effective equals 1 plus 0,069 over 4 to the 4. So I'm going to take 1 over the equal sign and then multiply it by 100. So it's 1 plus 0,069 over 4 to the exponent 4 minus 1. Multiply that by 100, I get 7,08. 7,08%. People, between the two, which one is better? Remember, that's going to be 0.81. That's just in case we needed that value. Between the two, which one is better? B is already better. Why? It's a higher interest rate. Did you see that? Let's look at C. C, sorry man, C, same story. I don't need to write the formula down again. So it's 1 plus I effective equals 1 plus the nominal, right, which is 0,085 over 12 to the exponent 12. Okay. What I'm going to do is I'm going to work it out, then minus 1, then multiply it by 100. So open brackets, 1 plus 0,085 over 12 to the exponent 12 minus 1. Multiplied by 100 gives me 8 comma. Yes? Sorry? Oh, wrong. So 0, 0, 6, 8, 5. Sorry about that. So 0, 0, 7. Is that correct? 0, 0. But multiply that by 100 for the right. One more missing. 7, 0, and 7. So which one is the best option? Therefore, B is the best investment. People, you guys understand? Is there any confusion? People, number 7 we did as part of our examples, not so? Let's go to number 9. Convert a nominal interest rate of 6.5% per annum compounded quarterly to a nominal interest rate per annum compounded monthly. So it's two nominal compounders, okay? So in other words, if you look at the formula is 1 plus I effective equals 1 plus I nominal over, in the first case, compounded quarterly to the 4. Not so. And then we're going to do, in the second case, you're going to convert that effective to a compounded monthly. Can you see that, people? So let's do the first part. I'll show you this is going to be an easier way to do it. So it's 1 plus I effective equals 1 plus I. Wait a minute. Which is 0, 0, 6, 5 over 4 to the 4. So your effective is going to be, over brackets, 1 plus 0, 0 over 4 to the exponent 4 minus 1. These are 0, 0.666 and number carries on. Or I could have used the rate as 6, 6 something percent. But what happens to this effective interest rate? It must then be converted to a different compounding, not so. There we say for the second part of the calculation is 1 plus I effective equals 1 plus I nominal over 12 to the 2. So it's 1 plus 0,066, the 12th root thereof, minus 1 times 12 is equal to I nominal. So therefore your rate, your nominal rate, will simply be 12 into the 12th root of, whoops, the 12th root of 1 plus 0,066 is the answer, minus 1. And we multiply it by 6, 4, 7. Is that correct? Yes. As I said, there's definitely an easier way of doing it. We know that 1 plus I effective equals 1 plus I to the nominal over 4 to the 4. That was the first calculation, not so. Then the next calculation was 1 plus I effective is equal to 1 plus I over 12 to the 12. That was the second formula I used there. Not so. But what do we notice? We notice that 1 plus I effective is that, 1 plus I effective is this. There we go. So that is, it has to be equal to that. So if A is equal to B and A is equal to C, what can be concluded? If A is equal to B and A is equal to C, therefore B is equal to C. On that same account, if 1 plus I effective is equal to 1 plus I over 4 to the 4, and 1 plus I effective is equal to 1 plus I over 12 to the 12. If that is the same, then this has to be. Can you see that? So what we do is we say, therefore, 1 plus I nominal over 4 to the 4 is equal to 1 plus I to the, over 12 to the 12. So we can now say, since that is a 6% compounded quarterly, so it goes into here. So it's 1 plus 0,065 over 4 to the 4 is equal to. Now I want to calculate I, not so. So I now say the 12th root of that. So I got rid of that exponent. We take the 1 over, becomes minus 1. I then multiply this answer by 12, and then I multiply the answer again by 100 to get that rate. So it's 12 into the 12th root of 1 plus 0.04465 over 4 to the exponent 4. Minus 1 times 100 gives you 6,47. Which is the same. Do you guys understand? Okay, if you feel that this is easier for you to understand, you go that route, no problem. If you understand what's going on here, you can do that this way. I think that's the end of this exercise, not so? Alright. In tomorrow's lesson, we're just going to wrap up 11.9. People enjoy the rest of your day. Good morning, class. The full lesson can be found in the description box below.